So this is a very important one. So the volume of this parallelepiped, okay, the value of the parallelepiped is the box product of ABC. So A, B, C are the you can take them as the adjacent sides. Okay, you can take them as adjacent sides with the same initial point. Okay, so this is basically generating that whole parallelepiped. Okay. Say for example you are considering this as CAB. Okay. Because we can do that, right? It's going to satisfy the cyclic order. So A cross B, C vector dot A cross B. So there will be some small angle over here. Okay, and we will have, so when you do the A cross B, okay, when you do A cross B, this will be A cross B, and the projection of C vector over A cross B, that represents the height of this parallelepiped. Okay, so what is the height of the parallelepiped? H is equal to C vector dot A vector cross B vector. That is the projection of C vector over the A cross B. Okay, so height into area, base area gives you the volume. Okay, just like a cuboid. How do you do it in a cuboid? Just like a cuboid, in a parallelepiped, height into base area. Okay, in a two-dimensional way you can also see that, right? A parallelogram's area will be same as the rectangle's area. Okay, looking at the adjacent sides, if the sides are same, then you can say that, right? So basically, sorry, I didn't mention this slide. Modulus of A vector cross B vector. Sorry. So that's how we take the projection, right? So basically the n cap, okay, C vector dot n cap, okay. So the height into the base area, height into the base area, A vector, modulus of A vector cross B vector. This is just a parallelogram. So that gives me what? So height we know already, that is the projection, C vector dot n cap into modulus of n vector, that is nothing but C vector dot n vector, and that is nothing but C vector dot A vector cross B vector. Okay, so of course. So this H is representing the height of the parallelepiped, this is the base area. Of course, this analogy this logic can be done for anything, like you can take B and C and you can take A, okay, B cross C and A in the same logic. Okay, the magnitude of 1/6 of the box product. So understand, a parallelepiped can be divided into 6 tetrahedron. Okay, so a parallelepiped, any parallelepiped can be divided into 6 tetrahedron. Okay, so one of them will be 1/6 of the volume. 6 tetrahedron means a shape which has 4 faces. All the 4 faces will be triangles. Okay, that's a tetrahedron. Okay, it just look like this. So if we have something like this and take a point, okay, just looks like this. Tetrahedron. So there will be like 4 faces. Okay, 4 faces, and all of them are triangles. Okay, so you can divide a parallelepiped into 6 equal tetrahedrons. Okay, so one tetrahedron will be 1/6 of the generating box product vectors. Okay, and the same way, so if this is a tetrahedron generated by this vector, so if I take like A, B, C, with this tetrahedron, you take 5 more tetrahedrons and you can make a parallelepiped. Okay, and the parallelepiped is nothing but that is generated from ABC. Okay, you can form a parallelepiped. It is a little bit hard to imagine that, but this is the case. So you can take 5 more like this, not from the center. It's not from the center. It's like this. Okay, you can actually like join these 2 points and and you can join these two. Okay, something like this. Okay, this is one side, this is one face, inge oru face. So there are 4 faces now, right? 1, 2, 3, base 4. Okay, like that. Like that you can divide it into 6. Resultant of AB, which one? The diagonal line. Down. Yes. A vector plus B vector. You can take it. This, and you can generate a parallelepiped. The volume of the parallelepiped whose sides are given as a very direct question. Just to make you get used to that formula. Okay, that's why they are asking this. So you can do it in any way you want. Try for OA dot OB cross OC. Just make sure that cyclic order is maintained. Okay. So OA dot OB cross OC can be done. But since we are talking about volume, though cyclic order is not very important, because we are talking about volume. Even if you are getting the value negative, you take the modulus. Okay, modulus எடுத்துக்கலாம், because volume is positive. D 4. Okay, so let us see. So we come to the important portion here. Okay, let this be. So consider 3 non-coplanar vectors. Okay, consider 3 non-coplanar vectors. We already studied this, right? This was a very fundamental theorem. So whenever we have a set of non-coplanar vectors, what can we say? We can generate another vector. We can generate a vector which is a linear combination of all these 3. Okay, you can represent a vector in the space, okay, with respect to these 3 vectors as a linear combination of these 3 vectors. So you can write this as P times of A vector plus Q times of B vector plus I used the R already, plus R times of C vector. Okay, now there is a question coming up here: how to find the quantities PQR? How to find the quantities PQR? Should I take something as a product? So say for example you take like this. Take the product of B cross C on left and right. Dot product of B cross C on left and right. So if you take the dot product of B cross C on right, this will become 0. B vector dot B cross C is 0. C vector dot B cross C is 0. Then this will only remain P into A vector dot B cross C. This is something we know already. So phi vector dot B vector cross C vector divided by the box product of ABC is P. Okay. Now there is a question arises like, what is this quantity then? Phi vector dot B cross C by ABC, box product of ABC. That is actually functioning like a unit vector. Basically that is a unit vector. You can take this as phi vector dot A vector dash equal to P. Okay, consider this as A vector dash. Okay, so here A vector dash is B cross C by the box product ABC. Okay, so now this A vector dash, B vector dash, C vector dash, this is going to form a system. Okay, system like IJK. Okay, this A vector dash, B vector dash, C vector dash is going to form a system like IJK. Okay, and it will also follow the rules of ijk. Okay, so this is called as the reciprocal system of the vectors. So in the same way you can do this also. So you can also observe phi vector dot b vector dash. So if I want to get q, what we will do? If you want to get q, what you will do? A cross c. Okay, a cross c. Okay, so in that case we will get b cross c. So c cross a, multiply it by c cross a, you will get q. Okay, so here b vector dash is going to be c cross a by a vector, b vector, c vector. Okay, and similarly you can say the c vector dash as a cross b by box product of abc. Okay, so this is a very important thing. Okay, so basically these are going to be the building blocks of the R vector in the three-dimensional space, where a vector dash, b vector dash, c vector dash is serving as the ijk. Okay, அதுதான் வந்து ijk, the new ijk. Okay, like that. So this is something you can write as. So phi vector can be phi vector dot a vector dash dot. So this is going to be my p, right? This is going to be p into a vector okay. Phi is any vector in the three-dimensional space where you are taking a vector dash, b vector dash, c vector dash as the basis vectors, like ijk. Similar to ijk, you can take these three as the base vectors to build the new vector. Okay, area, that is not the area, that was the height into base area. See, I specified this one. This was the height. Okay, this was the height into base area. So this denominator will get cancelled and you will get the box product. Okay. So try to find the value of this expression. So given that ABC are non-coplanar, PQR are vectors defined by these relations. Okay, then the value of this expression is what they are asking. So just substitute p vector, q vector, r vector in those places and see what is happening. Okay, do the normal vector operation. Okay, C is the answer. Yes. See, yes, everyone listen. A vector plus b vector. First we will look at this one. Okay, a vector plus b vector dot b vector cross c vector divided by box product ABC. We already know this is just a dot product of two vectors, and here there is a binomial term. So you can use the distribution law, okay, without any hesitation. So a vector dot b vector cross c vector, so that is the box product, okay, plus b vector dot p cross c, that becomes 0. Okay, 0 divided by ABC. This is going to give me 1. This is going to give me 1. In the same logic you can do this also. 1. Okay, this is also going to be 1. This is also 1. 1 plus 1 plus 1. Okay.